Hello students, welcome back again to the new videos after a long time. Now today we are discussing a Regula-Falsi method to find the root of an equation, algebraic equation. Okay, so it's a numerical method. Okay, we'll discuss an example based on this. Okay, fine. Now look at the things very carefully, and it is very easy one. In examination it carries nearly 6 to 7 marks. So we'll go step by step, and you can observe carefully. First you can write the formula. What is the Regula-Falsi formula? Okay, you write the formula is very simple, that is x equal to a into f of b minus b into f of a divided by f of b minus f of a. Okay, so after writing the formula, the second step we are going to find the interval. Okay, we are finding the interval in which the root of an equation lies. So this is the important step. Okay, so we are finding the root of an equation. So as we know that for substituting a one value, the given equation, first you can write what is f of x. F of x is x cube minus 2x minus 5. For example, let us say for x equal to 0, you will get negative value, and for x equal to 3, you will get a positive value, means the root lies between 0 and 3. So first substitute and observe. X equal to 0, you can substitute x equal to 1, x equal to 2, x equal to 3, and so on. Correspondingly, what is f of 0? Substitute 0 cube minus 2 into 0, you will get minus 5. And observe this is less than 0. Okay. Similarly, substitute 1, you will get minus 6, again less than 0. 1 minus 2 minus 5, you will get minus 6. Again, what is the f of 3? Sorry, f of 2. F of 2 is 2 cube minus 2 into 2 minus 5. You will get minus 1. Again, which is less than 0. Substitute 3 and observe, you will get 16, which is greater than 0. Look at carefully. By substitution of 2, you will get a negative value. By substitution of 3, you will get a positive value. Therefore, you can confirm that the root, only one root of given equation lies between 2 and 3. 2 for negative value, 3 for positive value. Or else you can also write in a closed interval 2 and 3, and these are the values of a is equal to 2 and b is equal to 3. Okay, fine. And you can observe carefully that, okay, you can observe one minute. Okay, you can observe carefully. By substitution of 2, just you can draw a number line, you will come to know. Okay, this is 0. By substitution of 2, you will get a minus 1. By substitution of 3, you will get a 16. 16 is far away from 0. So what we need to do is, we need to modify the values of a and b in such a way that the f of a and f of b values are very close to 0. I will repeat once again. We are going to modify the values of a and b in which the value of f of a and f of b is very close to 0. Obviously, this is -1 very close to 0, but 16 is not close to 0. We need to modify the values. So for that purpose, again I am going for modification. So that is, I will substitute f of 2.1. Okay. So that is, substitute x equal to 2.1 and observe what is f of 2.1. f of 2.1 is 2.1 whole cube. Okay. Minus 2 into 2.1 minus 5. By calculating this, you will get 0.061, which is greater than 0. So what you can observe is, you can write, therefore root lies between, okay, root lies between 2 and 2.1. okay, by substitution of 2.1, which is very close, that is 0.061 is very close to 0. okay, therefore we can write, actually we have modified the b value, so therefore we can write here a is equal to 2 and b is equal to 2.1. correspondingly f of a means f of 2. What is f of 2 value? Already here, which is -1. And what is f of b? f of b is f of 2.1, which is 0.061. okay, now let us go for iteration. okay, we'll go for iteration number 1. okay, so iteration 1 or approximation 1, I will write iteration 1. okay, you can write iteration 1 is, so you can write the formula, that is x1 is equal to what? A into f of b minus b into f of a divided by f of b minus f of a. Just substitute the value and observe, a value is 2, f of b value is 0.061 minus b value is 2.1 into f of a value is -1 divided by f of b is 0.061 minus of -1. So on calculation, you will get this value is 2.0942. okay, so therefore conclude that what is the first approximation or first iteration, you will get 2.0942. okay, so now once again, before using the iteration number 2, I need to verify the value of x, whether x takes, by substitution of x is equal to 2.0942, whether the given function f of x takes positive value or negative value. For that, I need to verify f of this x1. What is f of x1? 2.0942 is equal to, you people already aware of f of x. f of x is x cube, 2.0942 whole cube minus 2 times of 2.0942, right, minus 5. So on calculating, you will get negative, that is minus 0.00392 and which is less than 0. Students, in case of less than 0, less than means the first value in the interval. Therefore, we can say that the root lies between for substitution of x, it takes negative value, means root lies between 2.0942 and by substitution of 2.1 you will get 0.061, which is positive. Okay, the root, but this is, you can write this is 2.1. okay, for 2.1 which is positive, for 2.0942 which is negative. Therefore, root lies between 2.0942 and 2.1. okay, we'll go for second iteration. Okay, iteration 2. Okay, in iteration 2 again we'll write x2 is equal to a into f of b minus b into f of a divided by f of b minus f of a. Here the value of a is 2.0942, right, and b value is 2.1. correspondingly f of a by substitution of 2.0942 will get minus 0.00392, and f of 2.1 we have already calculated. F of 2.1 is 0.061. You can just watch by going back side. Okay, here it is, f of 2.1 is 0.061. okay, now let's move to find out the second iteration. Okay, just substitute x2 is equal to, a value is 2.0942 into f of b is 0.061 minus b value is 2.1 into f of a minus 0.00392 divided by 0.061 minus of 0.00392. okay, so on calculation you will get this value is 2.09455. Look at previously we have got in x1, in the first iteration we have got 2.0942. okay, in the second iteration we have got 2.094. so after decimal place up to 3 digits are same. okay, here instead of 2, here you have got 5. Still you can go for one more iteration to get the desired level of accuracy. Thank you so much for watching. We'll meet in the next video, students.